Hi everyone, I'm Matt Berg and my teammates are Michael Leon and Joseph Staff. The topic of our project is NFL draft pick value. To begin, I want to provide a little background information on the format of the NFL draft. The NFL draft takes place every April, and this is when teams can pick college football players to join their team. Beginning in 1995, the NFL draft format was changed to the format that is still in place today. That format is as follows. The draft has 7 rounds, and there are usually a total of 240 to 262 picks in each draft. Each team is given at least 1 pick per round. A very interesting and important part of the NFL draft is that teams are allowed to trade picks with each other. Teams that trade picks with each other obviously have some sort of methodology for valuing those picks, but this information is private. As a result, our group is wondering, well, how valuable is each pick in the NFL draft relative to other picks? The goal of this project is to determine the value of each draft pick, but the question is, how do you do that? Let's break the problem down. Intuitively, we know that the value of a given pick depends on the value of the player that can be selected with that pick. Therefore, we first need to come up with a way to determine the value of the players that can be drafted. In the NFL, there are many positions, so our valuation of players should be position neutral since every position is important. Therefore, in order to value players, we should use position neutral statistics on those players. This means that we can use position neutral player statistics to assign values to players that are drafted. We can then determine the average value of the players drafted with a given pick. This value can then represent the value of a given draft pick. We now know that we need to be able to determine the value of players. The best way to determine how valuable players are is to look at the stats they put up over the course of their careers. These stats need to be position neutral, so some of the stats we are going to use are career seasons played, career games played, career games started, career Super Bowl MVPs awarded, career NFL MVPs awarded, and career offensive or defensive player of the years awarded. To collect this data, we went to the Pro Football Reference website and gathered these statistics for every player drafted into the NFL between 1995 and 2010. I'll explain why we chose these particular drafts later on. Now that we have stats on each player, we need to correlate those stats to the value of each player. We do know that the best players each season are named to the Associated Press All-Pro team. The All-Pro team is relevant to the draft because NFL teams want to draft players who will go on to be All-Pros. Therefore, we went back to the Pro Football Reference website and we assigned each player who had been named an All-Pro at least once in their career a value of 1. Any player who had never been named an All-Pro was assigned a value of 0. We started doing this for players who were drafted as early as 1995 because this is when the modern draft format was adopted. The last draft we included in our data was the 2010 draft. In order to make sure that our analysis is accurate, we want to make sure that all players have at least 10 seasons to earn an All-Pro nomination. The data we have gathered includes career statistics for each player and a binary value for each player that indicates if they were ever an All-Pro. Therefore, we are now dealing with what is basically a clustering problem. We want to assign players a value that indicates how likely they are to belong to the group of players that have been named All-Pro at least once. We want to do this based on a player's career statistics, and we want the values assigned to players to be evenly or smoothly distributed so that we can accurately represent the relative values of the wide ranges of players in the NFL. The data analysis method we can use to solve this problem is logistic regression. Given a vector of data, logistic regression can be used to calculate the probability that the vector of data represents either a 1 or a 0. If the probability of being a 1 is greater than 0.5, the vector of data is assigned a 1. Otherwise, it is assigned a 0. Therefore, in terms of the NFL draft, we can use logistic regression to calculate the probability of a player being named an All-Pro given their career statistics. This probability value will then represent the actual value of the player. The higher the probability, the more valuable the player is. In order to use logistic regression for this problem, we assumed that player career statistics are linearly related to the log odds of a player being an All-Pro. We also assumed that a large enough data set was gathered. In order to actually implement logistic regression, we wrote code in Python. Logistic regression requires a training data set, so we used the data from the 1995 draft to the 2005 draft to train our algorithm. Logistic regression is an iterative algorithm, so we experimented with the algorithm and found that it worked best when we capped the number of iterations at 200. The algorithm itself uses the cost function at the bottom of the screen to learn a probability function that accurately determines if a player belongs to the All-Pro group. The general form of the probability function is displayed with a light blue background. Next, we took the probability function produced by the logistic regression algorithm and used it to model all of our data. For every player drafted from 1995 to 2010, we calculated the probability of that player being an All-Pro given their career statistics. The model correctly classified players as either an All-Pro or not an All-Pro 90% of the time. At this point, all players in our data set have been assigned a probability that represents their actual value as a player. The larger this number is, the greater the value of the player. We now need to determine the value of the average player selected with a given pick. To do this, we calculated the average value of the players taken with each draft pick from 1995 to 2010. The result of calculating these values is shown in this graph. As you can see, there is a general trend of the early picks being a lot more valuable than later picks, but the data is somewhat scattered. To help filter out the noise in this trend, we grouped the draft picks together. For example, we grouped draft picks 1 through 5 together and made them into just one data point. This data point was represented by the middle draft pick, pick number 3, and the average value of the draft picks 1 through 5. We did this for all draft picks 1 through 240. We didn't go beyond 240 because some of the drafts did not have more than 240 picks. The results of grouping 5 consecutive draft picks together are shown in this graph. As you can see, this has significantly reduced the scattering of the data points. The trend of the first 50 draft picks or so being much more valuable than later picks is much easier to see now. Now that we have basically smoothed the data by averaging it, we can fit a trend line to the data points. The type of trend line relationship isn't very obvious just looking at the data, so we experimented with different techniques. Our intuition told us that the value of the draft pick should decrease as the pick number increases. Given this information, the best success we had modeling the data came from first taking the log of the inverse of draft pick value. After doing that, we experimented with fitting both a linear equation and a quadratic equation to our now processed data. The quadratic equation did a slightly better job of capturing the rapid increase in draft pick value that starts around draft pick number 50. Therefore, we chose the quadratic equation over the linear equation. Rearranging the quadratic equation just discussed and solving for draft pick value produced the trend line shown in this plot. The exact trendline equation is given in the plot, and it models how the value of a given draft pick compares to the value of another draft pick. The r-squared value of this trendline is 0.79. A perfect trendline fit would result in an r-squared value of 1, so clearly our model is not perfect, but it does do a pretty good job of representing the data. We now have a model for draft pick value, but as mentioned, NFL teams do not release information regarding how they value draft picks. However, Jimmy Johnson was the Cowboys' head coach in the late 1980s and early 1990s when the Cowboys won multiple Super Bowls. During his time as Cowboys coach, he assigned relative point values to draft picks 1 through 224 and this information is now public. It is important to point out that he allegedly assigned these values without much statistical backing. However, since he was a successful NFL coach, we can assume that he has a strong understanding of how NFL teams actually value draft picks. Here's a visual look at the point values Jimmy Johnson assigned to each draft pick. As you can see, he assigned the first pick a point value of 3,000, and pick 224 was assigned a value of 2. Looking at the overall trends, it is clear that Johnson considers the first few picks extremely more valuable than even picks in the range from 20 to 50. Also noteworthy is the fact that Johnson places very little value at all in draft picks after pick number 100. We want to compare our model to Jimmy Johnson's pick values, but our model is not on the same scale as his is. We assigned picks values ranging from 0 to 1, while he assigned picks values ranging from 2 to 3,000. In order to accurately compare our model to his values, we scaled our model such that our scaled model assigns the same value to the 25th pick as Johnson does. Therefore, both our model and Johnson's values assign a value of 720 points to the 25th pick. The results of scaling our model as such are shown in the graph. Johnson's pick values are also shown. As you can see, Johnson assigns much more value to early picks than our model does, and he assigns less value to later picks than our model does. Overall, Johnson's values indicate a much larger range in pick value than our model believes there is. Now that we have compared our model to Johnson's, it is important to see how that compares to the findings of our peers. Many people, such as those at the Harvard Sports Analysis Collective, have argued that Johnson assigns too much value to early picks and not enough value to late picks. Our model agrees with this assessment. Early picks are in fact more valuable because you have more players to pick from, but it turns out that teams aren't very good at identifying the players who will perform the best in the NFL. On average, the first few picks can only be expected to become all-pros 25 to 30% of the time. Furthermore, very good players can still be picked with later picks, so these picks actually have some relevant value. A great example of this is Tom Brady. He is considered to be one of the greatest football players of all time, yet he wasn't picked until the 199th overall pick in the 2000 draft. Therefore, it is clear that a pick is only as valuable as a team's ability to evaluate players allows it to be. As we saw earlier, the average value of each individual NFL draft pick is pretty scattered prior to group averaging. Ideally, we would like to be able to remove some of this scattering from our model without having to use group averaging. One way to do this might just simply be to collect more data. We didn't collect data from before the 1995 NFL draft because the draft format was different then. However, teams still picked a total of over 240 players in those drafts before 1995. Therefore, before the final project is due, we will collect data on players drafted going back much earlier than the 1995 NFL draft. We hope that this will help average out and smooth the average value we assign to each individual NFL draft pick. Once this additional data has been gathered, we will adjust our model to reflect the additional data. Doing this should make our model more accurate. Here are the references we used. We hope you found this video interesting, and thank you for watching.